Hi, everybody, and welcome to National Astronomy Week 2025. This is our second evening of observing the sky live. I'm joined by half a dozen astronomers from around the UK and in Spain, and we're going to be looking up to see what's on view for us tonight. Now, we've chosen this National Astronomy Week because we have the unusual circumstance of 6 planets on view up there in the sky at the same time. And 4 of them are so bright you can see them easily with your naked eye, and the 2 fainter ones I talk about as well. So arranged across the sky in this parade, starting over in the west where the sun has set, you'll see really brilliant Venus, brighter than anything else apart from the moon. And by the way, the moon is with them tonight as well, just to add to the fun. Below Venus, we have Saturn, very near the horizon, as seen from the UK, but we'll be seeing that from Spain in a moment. Near them, the very faint planet Neptune. I saw it through a telescope last night, but you really do need a telescope for that one. Turn to the left, Jupiter, second in brightness only to Venus, and then lovely red Mars. National Astronomy Week, in case you haven't been involved in one before, happens every few years. And what we do is take a particular theme. It might be an anniversary, like the discovery of Uranus. The first National Astronomy Week was 200 years after Uranus was discovered, and we celebrated the 150th anniversary of Neptune as well. Or a special sky event. Halley's Comet in 1985 was a must, and in 2003, Mars was closer to the Earth than at any time in 60,000 years. But tonight we're focusing on the planets, and so let's go to Grant Boskill in Spain. I believe that you're capturing Saturn low down on your horizon. Can you get it in your telescope?
Yes, evening everybody. Just bear with me, and I'll share my screen. I'm afraid it's a little bit cloudy in Spain, so it's not the best view of Saturn that anyone would have ever seen. But you can definitely see the rings, and unfortunately, there's a bit of cloud going over, so you'll see it's very yeah, being affected a lot by the seeing over there, and it is quite low down, so there's a bit of color dispersion as well. But hopefully, you can see that.
Yeah, I can see that, and I can see the round shape of the planet and going like diagonally across. Are those the rings, which are, I think we're seeing very much edge on at the moment?
Very edge on, yeah. So they're quite hard to make out, especially when the seeing is this bad through the clouds. But hopefully the
Mhm.
viewers at home can see the rings there. Normally they're an absolutely spectacular sight. Visually, they're an excellent target for a beginner astronomer looking for a beginner telescope. A really good target, and it's always a wow moment when you see Saturn for the first time.
Mhm. Indeed. And I know Saturn is going to go behind the sun next month. And in fact, when it's behind the sun, we're going to be go through the ring plane, as they call it. So we see the rings exactly edge on. And the disappointment for us as astronomers is because the sun will be so, right in front of Saturn, we won't actually see that magic moment of the rings edge on. But when it comes around back into the morning sky later this year, we'll be seeing the rings thin, but actually seeing them from the other side, from the other perspective. Oh, here, we're a bit brighter there.
A little bit brighter, yeah. It's just trying to
Yeah.
get them. If I blow it too much, then it's going to get very noisy. But I'm having to overexpose just to fight through the cloud cover
Mhm.
over there at the moment. So it's a little bit of a balancing act at the moment, unfortunately. Um, I mean,
Mhm.
there's pockets of better seeing, and you might see a little bit more surface detail popping through. On a good night, you will definitely see some surface detail and some weather bands coming through there. But yeah, unfortunately tonight, I think that's the best we're gonna get of Saturn.
Mhm. Did you manage to catch any images of it?
Um, we, we
Mhm.
we got a capture earlier, but to be honest, the capture earlier wasn't much better than this. And I've not had a lot to stack it yet. But if I get a chance in the background to stack it and it looks better, then I can share it up a bit later.
Okay, so thanks for that, Grant. We'll be coming back to you later on. Thanks for capturing Saturn, because I know it's not easy for any of us to get hold of it when it's so low down and moving down into the twilight as the minutes go by. And let's go now to Trevor Pitt. Do you have the moon, Trevor? And I think we were hoping to get an image of the moon.
Yeah, I'm okay. I'm just about to share my screen. Can you see that?
Yep, we can see now.
That one. How's that?
We can see you clearly now. Do you have
Can you
any
see
the
me?
moon of it? Yep.
Okay. Still there?
I'm still here. Yeah. Oh, okay. I'm seeing the moon. This is your image taken right now. Is that right?
Yeah, so this is the moon shown, and I can't see my zoom lens because it's got the that's right. So I'll zoom in onto the moon. There we go. And
Mhm. So what are we seeing here
so we're
on the
looking
moon?
at Mare Tranquillitatis, and I'll just move up a little bit and go up to Mare Crisium, which is there. And we can zoom in a little bit more into that one, up to 100%. And so we're looking here at Mare Crisium, and we've got some cloud going through. As you can see, every now and again it goes a little bit blurry, but we've got crater Proclus here, which is one of the brighter craters that you can see on the moon, and certainly during a full moon, then it's got some nice rays extending from it, from the ejecta, from the impact that it had. We
Mhm.
got crater Piccard here, a nice crater, and also we've got crater Pierce here. So those are showing up very nicely in this view. If I can just move down a little bit. So we're going down towards Mare Tranquillitatis, which is about there, and we're not quite seeing the Apollo 11, but I believe that the Apollo 17 landing site is just to the north of that area shown.
Yeah. Yes, so this is where Tranquility Base is, right in this big dark lava plain.
Yeah, and if we just go down a little bit further, we can start to see some of the larger craters coming in. I'm sorry, I can't name them all. There's quite a lot showing up there, of course, and I think if we just go down a little bit further, we should be able to pick up a few more bits of detail. Now, this particular crater here that's coming in the south, which is this one here, and you can see that is rather a large crater there, and it's a very old crater because, of course, inside that, then there's lots of other craters that have been impacted and had to be afterwards, of course. So quite a large crater there. I think it's called Jenner, that one. And the other ones inside there have got the designation Jenner A, B, C, D, and so on.
Right.
You did mention, I think, Fracasstatus a bit earlier on. I think that's this one here. Is that not the case?
Yeah, it looks like a good view there you've got. For those who are not so familiar with the moon, I wonder, could you explain to us, Trevor, why the moon looks so different from the Earth? I mean, we know the views of the Earth taken from space. The moon is clearly a very different body. For those who are not so familiar with our lunar companion, what's the difference between the Earth and the moon when it comes to its surface
Well,
features?
very simply, the Earth has got an atmosphere, and that causes weathering. The Moon doesn't have an atmosphere, and so basically, what you're seeing there is the remnants of the bombardments from the Great Bombardment, 4 billion years ago, down to about 2 billion years ago, and then continuously, as we all know, we get lots of meteor showers and things like that during the course of the year, and those rain down into our atmosphere and burn up as shooting stars. But of course, they land on the moon, and they gradually fill the surface up with regolith. It's the sort of a soil on the surface. The dust on the surface is really the remnants of these meteor particles which strike the moon as the moon passes through the same showers, exactly the same showers as we get. But of course, they don't burn up in the atmosphere because there's no atmosphere.
Yes, it's interesting to think that back in its early days, so billions of years ago, the Earth would have looked like this because of those impacts before we had weathering and water to smooth our planet over.
I think we would have had an atmosphere, of course, though, whereas the moon has lost all of that long since, but mainly because of its low gravity and no magnetic field, or a very small magnetic field to try and hold anything onto the surface.
Well, thanks for sharing. Thanks for sharing the moon. And the moon is always a beautiful sight, whether you have just your naked eye looking at it, or binoculars, or as in your case, a good telescope. Let's move now um, to from the moon to the second brightest object in the night sky nearby. It probably last night a lot of people saw that beautiful sight of the crescent moon near to the bright planet Venus. And let's take a look now and see what Venus looks like if you've got a telescope to see it through. And I think we have Steve Futcher in Hampshire is taking a look. Wow, yep, I can see Venus clearly in your shot. Tell us about it. Hey, can you hear me, Steve? We can't hear you. I don't know if there's a problem with your mic. Well, we can see clearly. Well, we'll try to establish contact with Steve. We're seeing Venus. So Venus is a planet about the same size as the Earth, but closer to the sun. And that means that as it goes around the sun, we see only a part of Venus illuminated at one time, which is the right-hand side here, where the sun is shining on it, and the left-hand side is in darkness. So rather like the phases of the moon. And as it goes around the orbit, we can see to us the crescent gets narrower and narrower, and Venus gets brighter. So at the moment, and here we're seeing the observatory. At the moment,
I lost my controls
hello?
there. So it's fading
Okay.
in and out a bit at the moment because I think we must have some cloud around.
Hi, Steve. We can hear you now. We had a bit of a problem with your audio earlier.
Yeah.
So, yeah, can you tell us a bit about Venus that we're looking at?
Yeah. So obviously it's quite a pronounced crescent here now, and obviously you've got the sun down to the left. All we're really seeing of Venus is the atmosphere. We're not seeing the surface of Venus. So we're seeing a lot of clouds on the Earth at the moment in between, though.
Mm-hmm. Yeah. So is it? Yeah. So tell us a bit about these clouds. It obviously is really bright, and Venus is totally covered in clouds.
Right. Yeah. This is a very small image on quite a large chip, so it's quite pixelated, unfortunately. So
Yes, I think we get the idea.
oh, it's gone.
Idea. I tell you what, I believe that Grant down in Spain has got Venus. I wonder if we could go through to Grant and see what we can get from there.
Hello
Hello,
again.
Grant.
Here we
Do you
go.
have Venus?
There you go.
Oh, yeah. I think what we're seeing here, I think the image is inverted because the crescent looks the other way up compared to Steve's view that we just saw.
Yep. Bear with me a second. Let me just try and bring it back into the center for you. Just bear with me a little tick more, and I will adjust. Sorry, it just takes a. I'm always going to press the wrong arrow first. That's inevitable.
Yeah, however clever the software is, always going to be something that can go wrong, and it usually does.
There we go. Let's just bring this a bit more. The mount's going to tell me off for pressing the button too many times. There we go. Let me see if I can just tweak the exposures. But I think you can clearly see the crescent, can't you? And might be able to just improve the focus a tiny bit there as well. See what we can do. Always going to be the other way.
Yeah. I know we were talking about focus. The other thing we're all seeing as we look at this is the images wobbling about like jelly. And that's not anything to do with Grant's telescope. That's because we're looking through the Earth's atmosphere. And particularly because Venus is low down, the atmosphere is shifting all the time, air currents blowing across and making the image wobble around. We call it scintillation, or it's the same effect that makes the stars seem to twinkle. And we talk a bit more about that later on as well. So tell me, Grant, clearly with the naked eye, Venus looks like a point of light, like a little lantern hanging in the sky. Can you see anything of Venus through binoculars, or do you need to have a telescope like
No,
yours?
you can definitely see the phases through. It depends how steady you can hold your binoculars. That's always the challenge with binoculars and the planets. It's always worth getting something like a monopod or using a gatepost to lean on. I find holding binoculars for planets very tricky. One little trick is most people, you hold your binoculars near the eyepiece, but actually if you hold your binocular at the other end, you can create more of a tripod against your body, and that can really help with a pair of binoculars. But definitely it's worth trying binoculars on the planets. A small a beginner telescope will give you better views, will be more stable, and will often give you more magnification. But absolutely give binoculars a try. Just be
Mhm.
careful where the planets are in relation to things like the sun. Um,
Yeah, okay. So it's better reviewing it at night time. I know some people say you can see Venus better during the daytime because it's not so dazzlingly bright. But as you say, you have to be very careful you don't
But be
accidentally
very,
put your
very careful as a beginner,
yes, yeah.
especially with solar filtration. If you're doing that, you've got to know what you're doing. As a beginner, I would just recommend waiting until night time and doing it being absolutely safe.
So how about the phase of Venus? We all know that the phases of the moon change as you watch from night to night. I mean, clearly Venus moves more slowly than the moon. How is this crescent going to change if you carry on watching over the next couple of weeks, say?
Oh gosh, you put me on the spot there. I wasn't prepared to talk about Venus. I don't know which direction it's going, to be honest.
Okay, I think it's coming towards us, so I think we're going to find it's going to get a narrower crescent as it comes towards us. But in my notes, it says that Venus is going to be at its brightest in a couple of weeks, and bright is bright. It's very bright anyway, but it will, I think, get brighter over the next couple of weeks. But that's it looks really, really, really lovely view. So that's probably as much as we can see on Venus. It's low down, it's got clouds, so we can't see the surface. Let's now talk about the second brightest planet we can see in the sky, and that's Jupiter. So if you're out looking at the night sky, looking at Venus, look 90 degrees to your left and way up in the sky, and you see brilliant Jupiter. And I think that Chris Hooker has Jupiter in his scope. So if we can go to Chris, please, let's see what you got.
Yeah, hi, good evening. Can you hear me okay?
Yeah, I got you here. I can hear you. Yeah,
My audio, right? Okay,
I
well,
can see you now as well.
share my screen.
Hmm.
That's even better, right? Let's share that.
Oh, yeah, lovely.
Okay, can you see that all right?
Yep,
So
I
I've
can see
got
that very clearly.
that's Jupiter. This is with a 10-inch Newtonian reflector, just in my back garden in South Oxfordshire.
Hello, Chris, having a
Um,
problem with you? Oh, yeah,
you can
you're back
actually
again. I've had a bit of
see
problem with the
the
audio,
red
but you're
spot.
back.
You also see the two dark clouds. Okay, I've got a thing on my screen saying my internet. So yes, there are two dark belts on Jupiter, as you can see, and the red spot is near the southern one, like that. Now we can also see one of the moons just there, which is a bit faint unless I turn the gain up. If I do that, you can see
Yeah, we got it now.
that moon off to the side. That is the moon Io, which is the closest one of the four bright moons. Let me just tweak the focus a little bit. There we go. And that's the one that's got all the volcanoes on. That was discovered by one of the NASA probes as they flew past. There was a plume of sort of the edge of the moon, and they realised it was one of the most volcanically active places in the solar system. It orbits
Which is
quite
amazing
close
for a
to
small
Jupiter.
moon.
Yeah, the reason is that its orbit is not quite circular, so it's because it's so close to Jupiter. Jupiter's gravity kind of pushes and pulls on it, and that causes the interior to have a lot of frictional heating, which is why. And then so the interior is probably molten, and that moves and things like that. So yeah, it's a very interesting place. If I turn that gain down a bit, now we get back to Jupiter. The other moons are too far away to see in this view, unfortunately. So we've only got planet and that one. But that's a reasonably steady view. That is actually in colour, although you wouldn't necessarily know that. But the
Hmm.
colour on Jupiter is quite subtle. If you take a video like this and then stack the frames and do a bit of enhancement, you can see that in the middle, the equatorial belt, there are some areas that actually look quite blue, and I'm not sure why that is. The red spot is on the inside by the storm. And then the belts, the dark belts are places where we're seeing a little bit deeper into the atmosphere. I lost my video. Um, so the lighter, the bright belts are the higher clouds in Jupiter's atmosphere, and then the darker bits are between the high clouds, and we're seeing lower into the atmosphere, so there's not so much light there. So I think that's
looking at
probably.
this image of, sorry, please carry on.
Go on. No, you carry on. I've
Yeah.
more or less finished what I was going to say. So
okay, the great red spot. I mean, we can see the color there distinctly. Well, no, not like a traffic light, but distinctly sort of redder than the rest of the planet. What's going on there?
which has been around for probably several hundred years. There are records of it long before we had from the 16th, well, not 16th, 15th, 17th, 18th century, where it's a huge red oval on the surface of Jupiter. And now it's been shrinking over the last few decades, and it's now actually, a great red spot. And there's speculation it might disappear altogether at some point and maybe be replaced by another storm, but we don't really know.
Certainly a dynamic world there, with weather even more extreme than ours. Thank you for contributing Jupiter to us. Now, we've seen Jupiter as the giant of the solar system. We've seen Saturn, which is the second biggest. Let's now go to another outer world, another giant planet, Uranus. If we can go over to who's going to have Uranus. Steve Broadbent, do you have Uranus in your telescope? Okay, just trying to call Steve Broadbent in Hampshire. So we're still waiting to see if we can get that link. Hi, Steve.
Hi. We're a bit clouded out here at the moment, but I can show you a picture that I took just before we came online.
Yeah.
So let me get my image up and then share a screen. So this is a picture taken with our 24-inch reflector at Cloudfield Observatory, and this is Uranus in the center there. If I zoom in on it, it's a bit grainy because it was this was just a 10-second image. So the center bright blob is Uranus, and in fact, 1, 2, 3, 4 are 4 of its moons. If I can show you a simulation, this is a program called Stellarium, which is showing you what the situation is around Jupiter at the moment. And we can see Umbriel, Titania, Ariel, and Oberon, which are 4 of the moons, are Umbriel, Titania, Ariel, and Oberon. So we can see 4 of its 28 moons, I think it's got on the last count. It's interesting with Uranus. If you look at Saturn or Jupiter and watch the moons, they go backwards and forwards either side of the planet as they go round, because they're orbiting in the same plane as the plane of the orbit of the planets. So they just appear to go backwards and forwards as they go in front and behind. But Jupiter has had a nasty accident, and is right.
Sorry, Steve. I think that's Uranus. I think I slipped
Sorry,
the tongue.
Uranus. Uranus is had a nasty accident and is right over on its side. So at the moment, the moons appear to go round and round in circles rather than backwards and forwards.
So
which
we're looking
is,
down on the pole of Uranus there, really.
yes, indeed. And later in Uranus's year, I think it takes 86 years to go around the sun. Then we will see it at a different angle where we'll be looking at the equator, and then the moons will appear to go up and down as opposed to side to side. So it's a strange setup, and nobody really knows why. They think it might have been hit by something many years ago and knocked it over. But anyway, there's the giant planet Uranus, and 4 of its brighter moons.
Yeah, and certainly the early solar system was a very violent place, so things were crashing into each other all the time. The best theory for the origin of our moon was that something hit the Earth and splashed out rocks into space, which solidified into our moon. And clearly, Uranus had an even bigger one, which like totally knocked it sideways.
Yes.
Thank you for sharing Uranus. Any chance of a live view of it, or is it still cloudy where you are?
Let me just get rid of this. No, we're still clouded out, I'm afraid.
Okay. Well, good luck with it clearing up. I'll try to come back to you later. The final planet we can see tonight is with the naked eye. If you look to the left of Jupiter, and I should say for those who've got telescopes, if you're looking for Uranus, that's to the right of Jupiter. You've got Jupiter in the sky. You've got just above it the beautiful star cluster called the Pleiades, or Seven Sisters, and Uranus is a bit to the right of there. And technically, you can see Uranus with the naked eye, but it's right on the very limit. Binoculars will certainly show it, and obviously a telescope will show you more. But let's go back to Jupiter. Let's see if Grant in Spain has got a clear view of Jupiter. Grant, any luck with Jupiter at the moment?
Absolutely.
Good.
Here we go. So we can actually
yeah, that's
we can do a bit of magic trick with this one as well. If you can just bear with me 2 ticks, we can
Sure.
we can swap to a different camera, and so we're going to have to refocus. So just bear with me. We should get a much bigger image scale. Which should show us a fair bit more detail. I'll recenter it.
I can see it sharpening up there.
Yeah, so it should give it another tweak on the focus. Always the wrong way. But that should.
So we're seeing clearly those pale coloured zones we were talking about, and then the darker bands we're looking down further into Jupiter's atmosphere, where the clouds are tinted by probably sulfur. Sulfur gives you coloured clouds, whereas methane will give you just pale white clouds. And Jupiter is just all gas, I should just say. Well, Grant is focusing this one up. So Jupiter is big enough, it's a giant planet, to contain 1,300 Earths inside it, but it doesn't have a solid surface of any kind. It's just made of gas all the way through. So what we're seeing, it looks like a surface, are just some bands of cloud. If you went down into there, the atmosphere gets thicker and thicker until the gas is so thick it behaves like a liquid. And then we go down to Jupiter's core. And the latest discovery from NASA's Juno mission is there isn't even a solid core, that probably rocky stuff there, but it's mixed in with the inner layers of liquid. So it's really just like a muddy core in the middle.
We've still got a little bit of cloud in Spain, so I think that's probably the best we're going to get with this amount of magnification.
Is it possible for you to do a real-time stack of those to get a more detailed photo? Was that? I'm not sure what equipment you're using there.
Yeah, I'm using SharpCap, and it is. Unfortunately, when I tried it a few seconds ago, it was producing some strange results, but I can leave it running for a few seconds and see if it cleans itself up.
While you do that, could you explain about your observatory? I believe you have more than one telescope down there, several telescopes. Is that right?
Yeah, so we're using a 10-inch Cassegrain telescope for this setup, which actually has 4 different cameras on it, so we can change the resolution we're imaging at remotely. We're probably pushing it a little bit too much with this particular camera on, given the seeing conditions this evening, but it's starting to to clean up quite nicely. But we do have several telescopes we use for outreach and training purposes in our remote observatory in Spain. So this has come from the south of Spain, in a place called Castilla, which is in Granada. It's normally very clear there, but this evening it's not so good. So it's good to see some UK clear skies as well. But hopefully you can see that this is sharpening up quite nicely. So SharpCap's doing a pretty good job. So red spots certainly coming in a little bit more on my screen. So hopefully you guys are seeing the same.
Could you explain to everyone just how the sharpening works? Is that what sort of program do you use for this?
It's doing in real time what we would normally do if we were taking planetary images, which is we would take, rather than taking a single image like you might do for deep sky, you're taking as many captures as you can in a very short space of time. So typically I would take 1,000 or 2,000 frames. So you're trying to run at a really high frame rate. You're trying to freeze the effects of those seeing conditions, that kind of swirly that we saw earlier, the swirling around we saw earlier. And then the software is very clever that it looks through all of those 1,000, 2,000 frames you've captured and will take the best bits from all of them and mathematically stack that whole video together into one final image, which you can then sharpen. And what this software is doing, which is SharpCap, which is free software, it's excellent software, great for planetary and solar captures. It's doing it in real time. So rather than you having to capture the video and then go and process it to get the end result, it's trying to do it in real time, selecting the best bits of the images it's captured so far and trying to sharpen them as we watch.
Yeah, I think it's really quite magical. I know you don't have the best seeing conditions tonight, but I know some shots that I've seen look almost like they're taken with people's backyard telescopes. They look almost like space probe pictures of some of these planets.
It is pretty remarkable the detail you can capture, and the software, particularly the amount of free software that's available these days, it really is a golden age for astronomy, I think.
Yeah, and I always think I'm really grateful. If anyone's out there, I'll shout out. Grateful to the software developers who actually give away their software free for people to produce some amazing images. So we're very fortunate we have people like that. Okay, thank you for Jupiter. Let's move on now to the next planet. And I've talked about Jupiter, Seven Sisters of Pleiades, and Uranus. If we go to the left of Jupiter now, there's a bright red, what looks like a star. It's next to two moderately bright stars, which are Castor and Pollux, the twin stars of Gemini. And right next to it is a brighter red object, and that's the red planet Mars. It was closest to the Earth last month, so it really was brilliant. It's fading a bit now because the Earth is pulling away. Mars is further out. If you remember the order of the planets, Mercury, Venus, Earth, Mars. Mars is in a further orbit, going more slowly. So what actually happened last month was the Earth caught up with Mars, and the Earth is now pulled past Mars. It's like it's on the inner lane going faster, leaving Mars behind. So Mars will gradually fade as we watch it over the coming months, but it's still close enough to us to get decent shots through a telescope. And I think now that we may have Chris on Mars. Do we have Mars, Chris? If we can go over to you. I'm not sure we do. So anyway, Mars is really the nearest to Earth in terms of a planet. Venus is more like the Earth in size, but it has that really thick atmosphere we talked about, which gives it a runaway greenhouse effect. So it's really hot. The temperature on the surface of Venus is hotter than your oven on its highest setting, so it's not a very hospitable place. But Mars has a thinner atmosphere. It's colder than the Earth, but we could walk on its surface and we could survive there in a spacesuit because the atmosphere is too thin for us to breathe. But Mars is really the place that we could go to for home. And I think that David Arditi may have Mars now. Let's see if we can take a look at our second home in space through David's telescope. Are you there, David?
Yes, I am here.
Hey.
Yes, I was slightly late to this meeting, playing the piano.
Oh, that's fine.
I was playing the piano earlier this evening. I see you've got a nice pump organ there, or harmonium in the background.
Yes. When you play with the pedals, I think it's called a pedal organ in America.
Yes, that's not particularly relevant to this. So Mars is very nice tonight.
Mm-hmm.
So
Oh,
you
yes.
will be able to see now the view through a 14-inch Schmidt-Cassegrain telescope located in the London suburbs. And what we see is an inverted image of Mars with south at the top, which is what you normally get through a telescope. So you've got the whitish North Polar cap at the bottom, and you've got one of the dark albedo areas towards the top, which is the Solis Lacus. And the lower part of the disk, the northern part, is a highland area which contains various volcanoes, the Tarsis volcanoes, which are some of the biggest mountains in the solar system, the biggest volcanoes, long extinct, of course. And so some lighter and darker patches, maybe a little bit of cloud in the northern hemisphere. That seeing isn't very good, actually. It's wobbling about quite a bit, but it's only about 40 degrees high, and it will get higher as the night goes on. And then seeing generally improves as the planet gets higher. It's slightly past opposition, so it's now moving away from the Earth already. I think it was about 25 arc seconds at maximum. Oh, it's gone very blurry now. I should think a plane has just gone through. That's the usual reason why you get that sudden
Well,
disturbance.
it stirs up the atmosphere, I mean, as the plane goes by.
It's probably a contrail.
Yeah.
So
Okay, here's coming back again now, yeah.
yes, we saw it last night as well through this telescope, and you get a very similar view if you look at Mars the same time each night, because its period of rotation is almost 24 hours. So there's a slight difference between the Mars rotation and the Earth, so it does advance over a few days. So by the end of the week, we will see a slightly different view. Mars, of course, has a very thin atmosphere, but quite a bit happens in Mars' atmosphere. You can sometimes see clouds on the terminator, and you can sometimes see dust storms, although the atmosphere is only 1% the thickness of the Earth's. Dust storms whip up from time to time, which can be seen from the Earth, and they can become global. And we have had some dust storms in this apparition, this year, this time Mars round. But they haven't been global dust storms, and the planet looks quite clear itself today, although the atmosphere is perhaps not that clear. In fact, it's a little bit fading out. I'll brighten it up a bit with the gain control.
Yeah, we see very clearly those red dusty deserts on Mars and the darker regions. I believe those change with the seasons. I think it's springtime in Mars's northern hemisphere with the polar caps. I think that image is inverted, if I'm right.
Yes.
Have you seen seasonal changes yourself when people talk about them?
Yes, certainly the caps change and the North Polar cap is contracting. It never completely disappears, but you do get fissures forming in it, like valleys where it becomes completely dry. It is ice. It's a mixture of carbon dioxide ice and water ice. And at certain times of the year, it gets covered with cloud. But this is quite predictable. It does more or less the same thing in each seasonal cycle, that the cloud clears at a certain time in the seasonal cycle, and it has now cleared, and we see the ice cap itself. And the seasons are due to the fact that Mars's inclination of its axis of rotation to its orbit is similar to that of the Earth. It's around 24 degrees. So it has a very similar cycle of seasons, although, of course, taking around about twice as long, because it takes around about twice as long to go round the sun. So we only get a good view of Mars really every 2 years.
Yeah, I wanted to ask you the $64,000 question about Mars. I know there's no right or wrong answer, but what do you think about life on Mars, either now or in the past?
Well, it wouldn't be surprising, would it? Since there's so much evidence of geological features carved by water on Mars, and the surveys done by satellites, probes, in orbit around Mars have show a lot of evidence that there is a lot of water frozen under the surface. So in the past, Mars's atmosphere was almost certainly much denser than it is today. It's been gradually stripped off by the solar wind over the 4 billion years the solar system has been going, because Mars lacks a magnetic field. Unlike the Earth, Mars doesn't have a strong magnetic field. It cannot deflect the solar particles, the charged solar particles. So those are knocking off its atmosphere. So it had a thicker atmosphere in the past, which could have had more clouds. It could have had rain clouds, and it certainly had the ingredients for life. So I wouldn't say it's likely that it ever evolved very far, but maybe single-celled organisms. I wouldn't be surprised. But we've got to go there and dig extensively to really get a good idea.
That's a great thought. So when we go out tonight and we see that red planet, just think that maybe there was life there, but certainly in the future our descendants will be traveling out there. Thank you for that contribution. We've covered the planets now, all of them that we can see. You may notice we haven't talked about Mercury. Now, it's the one planet that's not in the evening sky at the moment. It's the one we have to miss out on National Astronomy Week, but we wanted to capture the moon going past all the planets in turn. And later this week, we'll be talking about the moon going past Jupiter and then Mars. The Mercury we can't see at the moment. We wait till the end of this month, in a couple of weeks, Mercury will be appearing low in the evening sky near to Saturn. So if you want to complete your roster of planets, that'll be the time to catch up on the final one. But let's now move beyond the solar system, the family of planets that go around our sun, because there are a lot of things, of course, out there to see in space. And I know that Dave Eagle is looking in on, I believe, the Orion Nebula, which is one of the more spectacular sights you can see through a small telescope. Dave?
Yep, thank you, Nigel. What I've got, I'm currently on Messier 42, which is this nursery of stars. So stars are being made within this cloud of gas and dust you can see here. And I've got a C-Star S30 trained on that at the moment. And you can see it's just previewing at the moment. And if we zoom in on the nebulosity, so this is a cloud of hydrogen gas mainly. And you can see in the center there, there's these 4 stars very close together. That's what we call the trapezium in there. Now you can see it's taking series after series of images. You can see just how noisy they are. And when you're taking deep sky images, what you need to do, you need to take a number of images as long as possible. Now with the C-Star, it's on an altazimuth mount, so therefore it can't take very long exposures. But what it does, if I press the little red button on the side there, it's on the side on your screen because I've put it that way so it looks a bit bigger on your screens at home. And what it's now doing, it's now taking a series of images and it's live stacking them. So it's adding all those images together as we go. And it's aligning on the stars. So you'll see it should take an image and then it should start stacking. So there you go. That's
Wow.
a 10-second exposure. You see just how much more nebulosity. The trouble is, if we look in the center now, we're starting to lose that trapezium in the center. So you can see as it's starting to add up the data. And this is exactly what we do with deep sky images. We take as many images as possible and stack them together. And you can see just how much noise is in that image. But as we increase the number of images that we stack together, that noise will smooth out because the noise is random within each image. And so the more images you add together up to a point, that noise will smooth out. And so the more imagery we add, the more of your nebulosity we're going to see.
It's very impressive, Dave. I have yet to use one of these C-Star telescopes myself, but I know it's new technology. I'm just looking at the screen. When we looked at our previous contributors tonight and last night, to process an image, they had to go to a computer screen, adjust controls, click on integration times, and so on. But yours is doing it. First of all, it's obviously doing it live and it's doing automatically, but it also I believe you can't even look through these telescopes. Could you explain a bit more about the revolutionary design of these new telescopes?
Yeah, they're controlled with a smart device. So I'm using a mobile phone here and broadcasting that onto the screen. And so you connect it to the device and then tell it the objects you want to have a look at, and it just goes to the position it thinks it's in. It takes an image and then it works out the position of all the stars in the image. And if it's not pointing at the right place, it will then move to the right place and get the object in view for you. So they're a fantastic device, and they are going to get so many people into the hobby. It's going to be fantastic.
Really good. So you don't even have to go outside, provided your
You don't, well,
telescope is outside. You can sit inside just with your phone in your hand.
yeah, so I'm actually sitting inside at the other side of the house. The Sea Star is in the garden, and it's connected to my home Wi-Fi. And devices like the Sea Star, the ASI Air, and the other smart scopes, they all work very much the same. So yes, astronomy is now becoming a nice warm hobby rather than sitting outside controlling telescopes and taking images in the freezing cold. I can sit on the settee in the warm and do astronomy from there. Some people will say it's not quite the same, but you know, it works for me.
When I was a kid, I used to horrify my mother. I go out, had a 6-inch Newtonian telescope in my backyard, and in winter I go out when the snow was 2 inches thick on the ground, and I stay out for a couple of hours. Come in and have a hot chocolate afterwards. But my mother could never understand this fixation with going out in the cold.
Yeah,
But as you say, it's changing now.
still have to go outside and set it all up and then strip it down
Yes.
again at the end of the night. But hey, you know, it's these devices are fantastic, and you know, the more people we can get into the hobby, the better it's going to be, I think.
Oh, there's always something for everybody to see up there in the sky. I mean, I know when I have friends around, I mean, this week has been fantastic. Either just with the naked eye, showing them the planets, or I have a 4-inch telescope in my backyard, 100 millimeter, and just showing people that. Um, the Also, a few months ago, I'm in North Carolina at the moment. We had the comet that came around, Shan Atlas comet, which hit the headlines. I know it wasn't very good from the UK. I know it was really cloudy in the UK, but there were some good views from here. And everyone I showed that were totally wowed, and it does get people interested in the
Yeah,
universe around them.
I did manage a few images of that with the Sea Star as well. So, oh, hello, it's failed to stack, but that's okay.
Well, I think we've had a really good show. Um, okay, well, thanks for showing us the region of star birth. Let's go over now to Grant in Spain, if you're there, Grant. I think you've got some more what we call deep sky objects. Thanks, Dave. Deep sky meaning they're outside our solar system. They're like faint fuzzy patches, we
Yeah.
sometimes call them. So what do you have there?
So these are actually not from Spain. These are from my back garden in the UK. Spain, unfortunately,
Okay.
the clouds have set in and the roofs have closed. But luckily, it's reasonably clear here in Bedfordshire, and I've got some smart telescopes set up similar to Dave on some different targets. So let me just go to those. So I'm having to share this on my phone rather than my desktop. So just bear with me a tick. There we go. Can you see that?
Oh wow, yeah.
So this is California Nebula. This has been running. Let me see if I can hide myself. I don't know if it will let me on. Sorry. It doesn't let me hide the Zoom window. So you're going to see me in duplicate. You can see in the top right there. This has been running for an hour. I started this at the beginning of the session, and I've just left it running. I haven't touched it. But if you take a look at some of the detail that it's showing. It's pretty remarkable considering I literally just stuck it on a table and told it to go and image California Nebula for me. So they really are pretty remarkable devices. This is running from a C-Star S30. So yeah, I've not touched that. That's what's come off the device. And
Yeah.
my back garden is pretty poor for light pollution, and it's also quite tricky. I have to pick targets that are almost directly overhead because I'm surrounded by trees.
I'll ask you a little bit about light pollution, actually, because light pollution is it's obviously a big problem for us as astronomers, for anybody who wants to view the night sky. And just to, by way of parenthesis, to say the National Astronomy Week back in 1990, the third National Astronomy Week, picked light pollution as its theme. I was privileged to be chairman that time around, and before that, in the 1980s, people had never heard of light pollution, but we helped. We had a petition signed by the Astronomer Royal. We had a lot of media attention. So it did, people became much more aware of light pollution, but obviously we're still fighting it all the time, as you're saying there. Do you use any special filters?
Yeah,
And that's one way you can get around it.
I do absolutely, and there's several types of light pollution that I'm battling with. First is my children and insistence to have as many lights on as possible in the house. So they've been banned from the rear of the house and been told to turn all the lights off. So there's sort of local light pollution from them and local. I've had to turn off my Ring doorbell light and things like that. So there's the sort of localized light pollution. I've then got Luton and Hitchin nearby, which create sort of more general orange glow on the horizons. And the other light pollution I have is the airports near me. I have Luton and Stansted, and we now have quite a lot of satellite trails. So I think this image, if you zoom in, I did spot a satellite trail. I'm not sure it's going to show up there, but this particular smart telescope has a built-in light pollution filter, and you can see that's in place at the moment. Can you see? Possibly not from my screenshot. Yeah, there we go. Light pollution filter at the top is ticked. So it has a built-in dual band narrowband filter, which really helps you take images, particularly of nebula like this. It only passes a very, very narrow slit of light through those filters in the sort of wavelengths that we typically image, which are hydrogen alpha, oxygen free for this filter, which is what these type of nebula will be emitting in their brightest areas. And what that means is all the other wavelengths are blocked, and that can really help block the light pollution. Yeah, I mean, there's only so far they can go, but they do a very good job these days. And even in central London, you see some people getting some fantastic results when using the appropriate filters. And there's a whole gamut of filters available these days to suit different types of light pollution and to suit different targets and different telescopes. So it really, really has helped a lot. But as you kind of mentioned, the best solution is to not have the light pollution. So, going somewhere dark, or ideally people paying more attention to the type of lighting they install and how long they have that lighting on for. It really is wasteful chucking all that light up into the air. It's not needed in the atmosphere. So even just some simple changes to the lights you choose in your back garden can make a big difference to overall light pollution.
Yeah, one of our slogans for that National Astronomy Week was that light pollution is the only kind of pollution that when you're tackling it, you actually save money rather than spending money. And that because you're using less electricity, less, it costs less, and it saves on greenhouse gases as well. So it's win-win.
And the impact it has on animals is pretty remarkable, isn't it? The sort of nocturnal cycles of various animals are heavily impacted by our lights. And I think if you, I mean, we could talk about this all night, but I think if you actually look at the crime stats as well, having bright security lights doesn't actually help, is my understanding. In fact, it can sometimes make crime worse because you're helping potential burglars find their targets. So yeah, it's a big topic that we should pay more attention to. Just to mention, this is an hour's worth of image now. So, looking at what they've achieved in a few seconds, if you leave it running, this is the type of detail you can get after an hour. You don't have to leave it running this long, but that does really help. I've got another one running, which I will try and switch to. There we go. Just bear with me. There we go. So this is running from a different type of telescope. This is still a smart telescope, but it's the Celestial Origin. This has been running for a similar time. So this is image 443. It takes 10-second images. And this is another nebula, but again, you can see the type of detail you can start to get with these smart telescopes. Hopefully you can see that on the screen.
Yeah, I can see the name there, Pac-Man, and I can see the resemblance to the Pac-Man video game character. If you turn it on its side, you can see the mouth there in the middle of the circular shape.
Yeah, I mean, some of these objects have got some very strange names. I mean, the official name is NGC 281, which is not as exciting as the Pac-Man Nebula, and my children in particular like going for this one. So yeah, it's all good fun.
Okay. So thank you for that. We only have a few minutes left. Let's just go over to Dave Eagle again. I think he's got another deep sky object. And just to put into context, so far these nebulae we've been seeing, the Pac-Man, the Orion Nebula, are places where stars are born. And I hope, Dave, you've got the Crab Nebula, which is a place where a star has died.
I have. So here we are. There's the Crab Nebula. So this is now switched to a larger telescope than the Sea Star. And you can see there this cloud of gas and dust there. So this is a star that was seen to basically blow itself apart back in 1054, I believe. Chinese astronomers recorded it in Taurus the Bull. It's in the horns of Taurus. And when later astronomers with telescopes had a look at this patch that the Chinese astronomers said there was this bright light appeared in the sky, they found this cloud of expanding gas and dust here. So this is the remains of the star that's blown itself apart completely, and you can just about start to see the red tendrils there of the, let's zoom in a little bit, it's a little bit hazy still because it's only been going about 5 minutes or so. You can see those red tendrils there, which are all these strands, the shock wave coming out from the star, and the material that's coming away from the center of where the star was before it blew itself apart.
Yeah, and left in the middle of the Crab Nebula is a very strange object called a pulsar.
Pulsar,
which is,
yes, yeah, probably
tell
the
us more
most
about
studied,
that.
probably the most studied object in the whole sky, I reckon, that pulsar in the center there, because yes, it spins very, very fast. And it's like a lighthouse. It's got beams that swing out and they are directed backwards and forwards, so they flash very, very quickly, and so it gives us this very fast flashes as we observe it. So very, very interesting object right in the center there. So
It's
it's
a
a bit
very
hard to
interesting
say because it
story.
started off as a much bigger star which rotated slower, and then of course as it blew itself apart, it gets smaller. And if you watch a skater on an ice rink, if they pull their arms in, they start to spin faster, and that's exactly what's happened with that star.
Yeah, I mean, the pulsars were discovered in the 1960s. And if you take a photograph like you've got here, then because the star is spinning so rapidly, you don't see the flashes. But if you have a radio telescope or a special kind of optical telescope, you can see the flashes going on. Thank you for that, Dave. Just in the last couple of minutes, we'll see if we can pick up another nebula or two. Let's see if Trevor is available, because I think you might have another interestingly named object for us. Thanks again, Dave. Are we able to get Trevor? Hi there.
Yeah, hi. How are we doing? Is that visual now?
Yeah, well, we can see you now. I think you've got an interestingly named kind of nebula. As we were saying, they've got interesting
Yeah,
names to
so
them.
just a very quick one. We were talking about filters earlier. Grant forgot to mention one very important filter, and that's a cloud filter. This is a picture of the Running Man Nebula. You can just about see him. He's upside down, unfortunately, but he's lying in there in a lot of cloud. Now, this is a collection of images. I've got something of the order of 73 30-second intervals collected on this one, and just compare it with this one, which was taken same conditions, same sort of telescope, same time, same everything else, but this was 15 frames, and show the complete difference between the two, between this one here, which is about 3 times as long, and this one here, which is much clearer. And all the difference is because I've now got cirrus cloud up in the sky above me, which of course has taken out all the detail. So that's a very important point to remember, that you are limited, whatever telescope you've got, by the cloud.
Oh, absolutely. And I know it's frustrating for us to be observing from this country. Obviously, you can remotely operate telescopes in other countries, as Trevor has been telling us. And I know some people operate telescopes even in Australia from Britain or in Chile. So you can see our stars you can't see from here, but also better observing conditions.
Okay, I'll stop sharing.
Okay, thank you for that. So well, we're coming to the end of this program now. I'd just like to thank all of our contributors once again. And thank you for battling the clouds where you are, the observing conditions and the turbulence in the atmosphere to bring us the excitement of what it's like to see objects in the sky for yourself. So go out there, look for those planets, get your binoculars if you have them, see the crescent of Venus, see the craters on the moon, see the moons of Jupiter, all with binoculars. Or if you have access to a telescope, you're going to see even more. But whatever, there is something for everybody out there. We're in the second night of National Astronomy Week. It goes on for another 7 days, so do keep tuning in. Tomorrow at this time, Robin Scadgel will be bringing you more of the wonders of the night sky in National Astronomy Week 2025.